I'm sure you're all very excited to get back to our online lessons here, so let's go ahead and jump right into our fourth unit in Algebra 2, and that's going to be a unit on polynomial operations. To start this unit, we're going to have to look at a lot of vocabulary because there's a lot of words we're going to be using here that you need to make sure you're familiar with, the first one being polynomial. Now, I went ahead and looked up what Merriam-Webster's dictionary says the definition of polynomial is, and that's a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a non-negative integral power. That's really not very helpful. Simply, what we're talking about when we're talking about polynomials is simply an algebraic expression. It's a mathematical statement that involves algebra. So we have three examples here. Our first example would be 2x minus 3. That would be a polynomial. 3x cubed minus 5x plus 9 is another example of a polynomial, as is 7x to the fifth. So let's move on to some other vocabulary here. Things you need to know in this unit that we'll be using a lot are words like term. A term in a polynomial refers to the values separated by plus and minus signs. The example here, 3x squared minus 4x plus 1, has three terms. 3x squared is a term, negative 4x is a term, and 1 is a term. And you notice I associate that minus with the 4x, and that term value is actually a negative 4x. Degree is another word you're going to need to know. It refers to the largest exponent in the expression. So in this case, we have negative 5x to the 7th minus 4x to the 3rd plus 10. That would be a polynomial of degree 7 because the largest exponent is 7. Our next word is the word coefficient. We've talked about coefficients when we solved linear systems in three variables. Using matrices, we made a coefficient matrix, and all we were referring to is the numbers in front of the variables in a polynomial. So you look at the previous example here, our coefficients would be negative 5, negative 4, and 10. They're the numbers in front of the variables. Now a leading coefficient you'll hear a lot as well, and that refers to the coefficient on the variable with the highest exponent. Normally that will come first in the problem, that's why it's called the leading coefficient. We're referring to the value in front, in this case of x to the 7th, because that's the largest exponent. Our leading coefficient would be negative 5. And our final vocabulary term we're going to use here is called descending order. And that refers to writing your answers as a polynomial where your exponents go from least to greatest. So if you look at our examples here, we have two of them. Our first example refers to 4x minus 5x to the 3rd plus 7. That is not in descending order because our first exponent is 1 and our second exponent is 3. That does not work. They must go from least to greatest. So I've gone ahead and rewritten that statement, and you notice again the negative stays with the 5x cubed, and that goes in front because it's the largest exponent. Next we have the x, because that has an exponent of 1, and then 7 has no x's with it, so that goes on the end because it has an exponent of 0. So that's what we're talking about when we're talking about descending order. Your exponents should always go 5, 4, 3, 2, 1, or so on or so on. Now we're going to go ahead and use some of that vocabulary. We're going to look at classifying polynomials in two different ways. You can classify a polynomial by both its degree and its number of terms. This might remind you a little bit of geometry class when you classified triangles by both its sides and angles. You may have, for example, an isosceles right triangle. It can have two different classifications. The same thing applies here when we classify polynomials by both their degree and the number of terms. Now, you see here our left column refers to our number, our middle column refers to classifying by degree, and our right column refers to classifying by the number of terms. To begin with, let's look at the number 0 here. If something is of degree 0, you see it does not have a variable on it. The example here would be just the number 7. It does not have a variable on it, and so that would be of degree 0. We call that a constant, and it's called a constant because the number 7 will always have a value of 7. It does not change. And you cannot have something with 0 terms in there because if there's 0 terms, there's nothing there. So we can't classify something by terms if our number is 0. If you have something of degree 1, that means our highest exponent is 1. that's called a linear function because we have 3x minus 9, and as hopefully you all know, when we graph anything with a exponent of 1, you will get a line when you graph that. Something that has one term is called a monomial. Mono meaning one, and so therefore something like 4x to the fifth is only one term. It's called a monomial. The rest of these I'm going to go through a little more quickly. Something of degree 2 is called a quadratic function, and if there are two terms, it's called a binomial. Something that is of degree 3 is a cubic function, and something with 3 terms is called a trinomial. 4 for degree is a quartic function, and once we get past a trinomial, we don't name our polynomials anymore. It is simply a 4-termed polynomial. Same thing with 5 as far as the number of terms go, but if something is of degree 5, if it has an exponent of x to the fifth, we call that a quintic function. So that'll be the first part of your homework today. We'll be classifying your polynomials by both their degree and their number of terms. You're probably going to want to have this table in your notes, as these are questions on a test that should be freebies if you have good notes. Alright, and the last thing we're going to do today is adding and subtracting polynomials, and now this is going to be really quick because basically all we're looking at here is combining like terms, and so we've got 2 examples here of adding and subtracting polynomials. The adding example is much easier for most people because all we're doing is we're adding 3x squared minus 9x plus 5 to 2x squared minus 8x minus 11, and when we do that we're simply saying I take my x squared terms and I add those together. So I have a 3x squared and a 2x squared giving me a 5x squared. Then I have this negative 9x and I have this negative 8x. You'll have to excuse my circling, it's a little bit difficult. My negative 9x and negative 8x combine to make a negative 17x. And finally my positive 5 goes with a negative 11, and I add those together to get negative 6. So all we're doing is combining like terms. We're simply putting together our x squareds, our x's, and our number terms. Our second example is subtraction. That's slightly more difficult, only for the reason that you need to realize this subtraction in the middle here, that minus sign applies to everything in the second parenthesis. So when I go to do my subtraction, I have to say I have 4x squared minus a negative 3x squared, and so when you have 4 minus negative 3, it becomes 4 plus 3, which is 7x squared. So you just need to be careful with that minus sign in the middle, making sure you're applying it to everything in the second polynomial. 12x minus 6x is 6x, and negative 11 minus negative 5 is negative 6. So that's how we're getting to that answer. So tomorrow you'll have homework where you'll have to classify polynomials by both their degree and by the number of terms, and you will also have to do some adding and subtracting of polynomials.